Hi everyone. We are going to go through the 201 quiz on scale factor and triangles. We're going to start off with triangles. We learned earlier this week that there are two different ways that you can determine if a set of information would create a triangle. Well, here is a handy dandy flowchart that you can use and follow. I highly encourage you, if this is a topic that you know is a little bit tougher for you, you still haven't quite mastered it, to pause this video, take a little screenshot so you can add this to your notes or maybe even print it off and refer to it as you go through. With our screenshot here, with our flow chart here, we can either determine if a set of information is a triangle because they give us side lengths or because they give us angles. We're going to go through this flowchart in an example because I think that is the best way. All right, so here we have the question. Would the following set of angle measures create one, none, or more than one triangle? So for us to complete the first problem here, let's go to our flowchart. We are given a set of angles. I know that because not only does it tell me, but I also have the little degree symbols. All right, this is the path we're taking. So that leads us down to here. We want to know, do the angles equal 180 degrees? Because that is the requirement in order for something to create a triangle. Well, let's go ahead and add these up to see if we get 180. So 30 plus 50 plus 90 equals 170. So does that equal 180 degrees? No, which means we come to this part of our flow chart. So because we answered no, that means no triangle is created. That is not enough degrees. No triangle is created. Okay, let's clear off our flow chart here and try it with the next problem. We are still on the angle side, and we still need to ensure that it equals 180 degrees, but for our second one, our angle measurements are 60, 60, and 60. Add those three up, and we in fact get 180 degrees. Which means we're down here to yes. When we get 180 degrees, that actually means that more than one triangle is created. The reason for this is scale factor, which we're going to talk about scale factor a little bit later in the video. But remember, with scale factor, you can either enlarge or shrink a shape. Well, when you enlarge or shrink a shape by that scale factor, it doesn't change the angle measurements. Therefore, these angle measurements could fit within a teeny tiny triangle, a medium triangle, or a really big triangle. So it technically could create a vast majority of triangles because it equals 180. So this would be more than one because it equals 180. Let's go through our last example. If we look back at our flow chart, we're still with angles. We need to see if it equals 180 degrees. Let's add these up. 80 plus 120 plus 160. That equals 360 degrees. Well, when we look at that, one thing to figure out is, does that equal 180 degrees? No, it does not. We have way over 180 degrees. Therefore, that set of angles would not create a triangle. So your two answers here, even though three are provided to you, one of them is kind of like a trick because of that scale factor. Even though it would create a triangle, it could technically create multiple ones because we don't know the side lengths. Okay, now let's get into the flip side of that. would the following set of side lengths create one, none, or more than one triangle? Two reasons that we know we're dealing with side lengths. One, the directions tell us. And two, if we look at our numbers here, we have no degree symbols. Instead, we have our unit of measurement. So we are dealing with side lengths. That means we need to make sure that these lengths follow the triangle inequality theorem. Remember that the triangle inequality theorem tells us that any two sides of a triangle, when you add them up, it has to be greater than the third side. Because it can be any two sides, that means we have to do all the combinations. So with triangle inequality theorem, the thing to remember is you have to do it 3 times. You have to do 3 tests. I like to color code and do my tests in the same pattern every time because that helps me make sure that I don't miss a combination, nor do I accidentally duplicate one. So the first 2 sides I'm going to choose are the first 2. So in order for our rule to be true, the sum of these 2 sides, 5 and 8, are going to have to be greater than the third side, which is 12. Well, what would be 5 plus 8? 13. Is 13 greater than 12? Yeah, so that side meets our requirements. But because the rule states that any 2 sides have to be greater, we got to test it again. The next one I like to test are then the last 2. So 8 and 12. We need both 8 and 12 to add up and be greater than our third side, which our third side in this case is 5. Just by looking at that, I can tell it's going to be true, but let's go ahead and do the math. 8 plus 12 would be 20. Is 20 greater than 5? Yep, so it works. But don't forget, we have to do it 3 times, all of our combinations. So the last one I do are my 2 ends. So our first side and our last side. So 5 and 12 need to be greater than 8. 5 plus 12 would be 17. That is greater than 8. All 3 sides met the triangle inequality theorem. That would be a yes. Now, in this case, when our answer is yes, that actually only creates one triangle because the whole scale factor thing, that affects our side lengths. So we can't apply scale factor here because then our numbers would change. So when the side lengths work, one triangle is created. Let's try it again with another example. Would the following set of side lengths create one, none, or more than one triangle? This time we have 5 feet, 6 feet, and 11 feet. Once again, we're given side lengths. So we follow our flow chart, and that reminds us about the triangle inequality theorem. Let's go ahead, follow my pattern, just start with the first 2. We need to see if these 2 sides are greater than the third. Is 5 plus 6 greater than 11? Well, 5 plus 6 equals 11. What do you think? Is 11 greater than 11? No, 11 is equal to 11. It's not greater, which means this does not work. Therefore, when you get to a set of sides that doesn't work, you can stop because we don't meet the rule. These 2 sides are not greater than the third. Therefore, our answer would be no, and no triangle is created. To kind of give a visualization, that would be like you putting together these, if you had pieces of wood or something like that, and you were to put them together, it would look something like this, where there would be this gap. It wouldn't actually create a triangle. Those 3 pieces, there's no way that you could fit them together. and they would actually all meet up and make a triangle. You would have a gap somewhere, okay? We are halfway through our video. If you are watching this for review and you have plenty of attempts left on the quiz, that is awesome. But if you are watching this to unlock an additional attempt, you actually have 2 code words today. Here is your first code word, I'm. So jot that down, lock it away in your memory. So when you finish the video, you can email it to your teacher as proof that you have watched the video. The second half of this quiz of our topic from last week is all about scale factor. We mentioned it earlier. Now here we have it here. Before we even get to scale factor, I just kind of want to prove a little bit more that when you're dealing with angles, your only real option choices are it makes more than one triangle or no triangles. Because if we look at these, notice that your angle here is a right angle in each. And then I know we don't have any measurements, but if we did, these corresponding, so matching angles would still be equal. The scale factor doesn't affect that because it's either increasing or decreasing by the same amount. Those angles hold their amount. Okay, now that I've proved that, just for my sake, let's get into scale factor. With scale factor, that is the amount that we are either scaling up or scaling down our image. A lot of times this is used with maps, because if you want to have a map of the state of Florida, it wouldn't really be convenient or really even possible for you. It would be possible, but not convenient for you to have a map that is the size of the state of Florida. Okay, that wouldn't really be possible, would it? So we scale it down to make it fit on one piece of paper. So when you're looking at a map, 2 cities may look like they're only a couple inches away, where in fact, in real life, they are miles and miles away from each other. With scale factor, the most important thing is to make sure that you match up corresponding, otherwise known as matching sides. So if we look at our triangles here, our corresponding sides would be 4 and 12 because that is the same part of the triangle on each shape. And 3 and 9 would be corresponding. And then 5 and 15 are corresponding. Once you select the corresponding sides you want to use, the second always part of this is you set up your scale factor, you set up your fraction, you set up your division by having the second image over the first. Another way of saying that is it would be your new image, your scaled image, over the original, the OG, okay? In this case, we really should have an arrow here showing you which one's the first and which one's the second, but when they're lined up like this, if there's no arrow, there's no directions, the first one you see is the OG, the original. The second one is your new image, your scaled. So our second image, I'm just going to choose green. Those are the numbers I'm going to use. So 15 is the scaled version divided by the original. Once you set up your ratio here, throw in another word. We did ratios last semester. We're actually creating one with scale factor. Look at that. 15 divided by 5, do that simplification, would be 3. So that means this shape was enlarged by a scale factor of 3. All right, let's check this one out. This one's a little bit better. We have that arrow emphasizing it, and there actually is only one side provided. Sometimes that will happen. All right, let's set up our ratio here, set up our fraction. We need to ensure that the second image, the scaled version, is our numerator. And then the first image, our original, is our denominator. Now, sometimes when we have this here, we look at that fraction and we're like, ooh, I don't know the answer off the top of my head. You might have to actually do the division or simplify your fraction. Remember, ratios, fractions, those both represent division, all right? In case you didn't know this, let's think about our division sign. You know how we used to always use this for division? You see those dots? Those dots are representing a number. Look at our fraction here. I'm just going to use the number from last time because I don't have decimals to confuse it. 15 and 3. Those numbers are in replace of the dots. So you've always actually been using a fraction to mean division. Mind blown. All right. Sorry about that. Took a little rabbit trail off to that. Now that we know it's division, we've proved it. I'm going to set this up using long division. So it's 1 5/10 divided by 5/10. So the numerator is what's being divided by the denominator. 1 5/10 divided by 5/10. Well, we got a couple things going on here. We got decimals. Remember, with division, it is a-okay for you to have a decimal under your division bar. That's totally fine. What is not allowed is a decimal here in your divisor. So we need to move that over 1 point, 1 space to get rid of our decimal point. But of course, we need to keep things even. We need to keep it equivalent, meaning we also need to move this over. So our new problem, I'm actually going to come way up here to ensure I have plenty of room, would be 15 with the decimal point at the end, because maybe I'll need it, you never know, divided by 5. Well, how many times can 5 go into 1? None. So put a 0 there, and now let's look at it as the whole number. How many times can 5 go into 15? 3. And that goes evenly, which means there are no remainders to where I would need to use that decimal point. So this one just happens to be the same answer. How funny is that? It has an enlargement, a scale factor of 3. We'll do one more before we get to our last concept. Sometimes with scale factor, you have an example like this, where it is a reduction. We are reducing it. It is getting smaller. That doesn't matter. It just means whenever you're reducing something, your scale factor is going to be less than 1. So it'll either be written as typically a fraction or a decimal, because it'll be less than 1. But the process is still the same. We take our scaled image, so that second picture, and we are going to divide that by our original. 3/21. You could divide this and turn it into a decimal. And if that's what your answer choices ask, then that's what you need to do. Sometimes it'll just leave it as a fraction. Let's go ahead and reduce this. So remember, when we reduce fractions, when we simplify, we look for that common multiple. Well, both 3 and 21 can be divided by 3. So 3 divided by 3 is 1. 21 divided by 3 is 7. So our scale factor is it is reduced by 1/7. Okay, and last but not least, let's do a scale factor word problem, because these are set up a little bit differently. They're set up more like a proportion, because we've been doing ratios all along. And when we just have one ratio, it's pretty easy to simplify by dividing or reducing our fraction. But here we got a bit more information So we're going to set up a proportion to help us solve. Lisa drew a picture of a boat. She used the scale 1 inch for every 6 feet. The boat in her picture is 7 inches long. What is the length in feet of the actual boat? I am going to set up my first ratio based on the scale that was used. When I set this up, I always include my labels because that helps ensure that both of my ratios are set up the same. Now, what we're trying to figure out here is we know the boat in her drawing is 7 inches long. Well, for our scale factor, inches is in the numerator. For my second ratio here, we're going to make sure that we also put 7 inches in the numerator. And then our question is we want to know the length of the actual boat. Some of you may be able to just look at this and figure it out. If you're not able to, no worries. You can solve it like proportions, which we worked on earlier this year. If we choose to solve it like a proportion, I'm going to replace that question mark with a variable, because remember that's what a variable is, an unknown amount. And we know these two ratios are equal because of that scale factor. With proportions, these two are equal to each other. We are going to solve by cross multiplying. Here we multiply 1 inch times x. Well, 1 times anything is itself. So 1 times x is just x. Then that is set equal to you multiplying the other cross. 6 times 7 would be what? Hopefully you said 42. That means our boat is 42 feet in length. All right. Let's now get to our final code word, which is amazing. All right, we had our first code word earlier. Second is amazing. If you have attempts left, go forth. Take the 201 quiz. If you are watching this to earn an extra attempt, please make sure you email your teacher and say, hey, Mrs. Elstock, can I have another attempt on the 201 quiz? Here is the code word, or in this case, code words. All right, good luck, guys. If you have any questions, make sure to send your teacher an email. Bye.